Your story on big oil, of course, leads us to the feature we promised you. Here's Joe Murray on climate change.
Hello, I'm Dr. Joe Murray talking to you today on News for Scotland about climate change. For those of you who have not instantly switched off, I will continue. She wasn't the first, of course, but when Scotland's First Minister at the time, Nicola Sturgeon, came out and stated that the world does indeed have a climate emergency, there were many who refuted the scientific evidence. Most of them were, or are, those who make billions from causing the damage. However, the First Minister was not wrong, neither are the kids who have been striking and demonstrating to bring the problem to wider attention. After all, it is their future that we're talking about here. It's beyond time for all of us to acknowledge their pleas and accept that we are putting our children and grandchildren's futures in serious danger. We and recent generations have borrowed from these futures far more than we should have, and we must not leave our grandchildren with a debt that they may not be able to pay. The first thing we need to ask ourselves is, do we seriously believe that all these clever people, scientists with master's degrees and PhDs, have spent their adult lives studying and researching earth sciences simply to tell you lies? So what is climate change? Well, I declare myself at the outset as an ecologist and environmental scientist with a PhD, and for my sins I am also a writer and poet. So for me, all my research in the past convinces me that environmentally things are not as good as they should be. If I'm honest, I would have to say that they're actually becoming quite grave. Things are becoming bad because not enough people are paying attention. And this is likely due to vested interests who cause the problems, having no wish to change, and they work very hard to convince enough people that the problem doesn't even exist. So it is business as usual, and the money continues to pour into corporate cash drawers. The question to ask is, what price your own existence? So how do you not notice that such a danger is creeping up on you? Well, in relative terms, our world is quite big, and up until recently, changes have been subtle, so most people simply missed them and ignored the warnings. But not earth scientists whose job it is to pay attention and to notice these things. For the layperson it can be confusing. Scientists say this, the media say that. Scientists say one thing and large corporations say the other. Politicians side with money and power and tend to ignore knowledge-based information. Why rock the boat on a good career? And yes, like all human beings, scientists get things wrong. But the vast majority of them at the same time on the same subjects? Well, you need to think about that. I think the layperson should always ask themselves, who stands to gain most from ignoring the warnings? So you know, our world has been warming for 10 or 12,000 years, and global warming is happening as we speak. It would be happening even if we still lived in caves. So what's the problem? Well, the problem is the increase in speed of the change. Why is that a problem? Well, humans do not adapt very quickly, and a huge proportion of humanity live along coasts that will disappear under rising seas as they warm up more quickly. These areas also tend to be very fertile, and their agricultural loss to humanity will be great. Move on or starve. The rapid loss of glaciers is a huge problem too. Glaciers are nature's water banks. We live off the interest that fills our rivers, creates fertile plains in many areas. When they are gone, and lands become barren. Move on or starve. The Earth's nature is a wonderful system that is able to balance itself through many different cycles and by release and sequester systems. What it gives out it can absorb in the same time frame, retaining balance. However, if more waste products are released than it takes longer for nature to absorb, it remains in the systems for longer as pollution, and we all know what pollution is on land, air and water, yes? Humans appear to be interfering in that system, and there are more and more of us every year. There were only 3 billion people living on Earth when I was born in the 1950s. There are around 8 billion people now, with the population still growing. Add to that, our technologies allow us as individuals to consume even more than previous generations. So not only has the population increased, but each person consumes like a much larger person. The laptop you may be listening to me on weighs around, 2 kilograms? However, the manufacture of it is very energy intensive, and that will create around 350 kilograms of CO2. How many laptops are there in your home? How many are in your office? How many do you see in the coffee shops? The production of every 3 laptops you have ever seen emits a tonne of CO2. How many do you think exist in the world right at this moment, or have existed in the past 20 years? So let's look at Scotland and its climate. Scotland is a small country with a population of just over 5 million people. More than half the population lives around the Central Belt. The country has a temperate climate due to the North Atlantic Oscillation, or the Gulf Stream as it's more commonly known, which flows from the Gulf of Mexico along the west of Scotland and north to Iceland. January and February are usually Scotland's coldest months, with average daytime temperatures of 5 to 7 degrees C. It's the exception for temperatures to fall below -5 or -6. Even then, it's usually inland and away from the moderating coastal areas. In recent years, winters have been less severe and show a falling trend in the 20-year mean of degree day calculations at 15.5 degrees C. It doesn't snow in central Scotland as often as it did when I was a boy. My sledge got a lot of use back then, when runs could be there for many days, or even a week or two. You hardly see a kid on a sledge these days. If so, it's usually for just a day or two, if that. Without being too scientific, let us, as simply as possible, take a look at the situation as it stands. Many people mistake climate for weather, and while they're similar, they're not the same thing. Weather is the day-to-day atmospheric conditions at a location or a region, the temperature, precipitation, rain that is, wind and humidity. Climate is the atmospheric conditions over a location over a much longer period of time. Changes in weather can be dramatic, but changes in climate are usually more subtle. Climate is determined by long-term weather patterns at a location or region by values of certain atmospheric elements. These are air temperature, humidity, type and amount of cloud, type and amount of precipitation or rain, air pressure, wind speed and direction. A change to one of these weather elements may provide the impetus or changes in other elements. Scientists look at 20-year or longer means or averages, and by comparing lots of these data gathered over time can identify the climate trends. Meteorological scientists for a long time now have been forecasting changes to climate due to Earth warming up. So how do we know that the Earth is warming up? Well, no one disputes that. We all know of the greenhouse effect. The dispute is what is causing this effect to be enhanced. But let's look at the greenhouse effect. What is it? In 1824, the Frenchman Jean-Baptiste Fourier predicted an atmospheric effect which keeps the mean temperature of the planet higher than it would normally be. This effect later became known as the greenhouse effect, the analogy of which is a simplified view of what is a complex process. But let's look at this simplified effect. In a greenhouse, the glass allows short-wave ultraviolet light to pass relatively freely and gives off long-wave infrared light, which does not pass back through the glass very quickly, therefore remains and heats up the space. The Earth does not have a glass roof, but atmosphere works pretty much the same way as the glass. Nitrogen and oxygen between them make up 99% of our atmosphere, but they do not restrict the passage of infrared light, therefore do not contribute to the greenhouse effect. Among the remaining 1% are gases including water vapour that create the greenhouse effect. These many other gases are trace elements in the atmosphere, and in relative terms they are very small amounts of each. Carbon dioxide and methane and some other gases make it difficult for heat to escape, so the planet heats up. So let's look at a little of the science. The natural gases in the atmosphere affecting the greenhouse balance are, as I've said, carbon dioxide, water vapour, ozone. Others contributing gases are methane, nitrous oxide, sulphur hexafluoride and chlorofluorocarbons, which we all know which have been affecting in the past the ozone layer. Greenhouse gases are not limited to this list. They are all trace elements in the atmosphere, making up, as I have said, only 1% of the atmosphere. The greenhouse effect is not a bad thing. It is, in fact, crucial for life as we know it on Earth, because without it the mean temperature of the planet would be around -20 degrees centigrade. The planet would be like a snowball, far too cold for life as we know it. 1 or 2 degrees of a rise in today's mean temperature of 15 degrees. It may not sound like much, but the little ice age that affected Europe from the 14th to the 19th centuries was caused by only 1 degree drop in the mean temperature. So it doesn't take an awful lot to change things. And it all has to do with the amount of energy reaching the Earth from the Sun and how much of it is radiated back into space via the albedo effect, which is the reflection of the Sun's energy from clouds, ice fields, deserts, etc. The albedo reflects around 29% of all solar energy in the ultraviolet range. When it reaches the surface of the Earth, most of this energy is radiated back in the infrared range. Some of it is trapped by the greenhouse gases on its way out, and that heats up the planet. Otherwise, we would be freezing. The total quantity of solar radiation that hits our atmosphere, known as the solar constant, is 1.37 kilowatts per metre square. That means that 174 terawatts, or 174 trillion watts of solar energy strikes the Earth every second, and that's 10,000 times our total annual demand for energy. And it's all free. We tend to think of the atmosphere as huge and difficult for us to do much damage to. But let's have a look at that. Not counting the exosphere and the thermosphere, the official thickness of our atmosphere is approximately 100 kilometres. And most of that is in the troposphere, which is the lowest part of the atmosphere, which is about 12 kilometres above the surface of the Earth. However, and this is the important bit to remember, the part of the Earth's atmosphere in which we can live comfortably extends up only 3 kilometres from the surface. And for good reasons, not much lives above that height. So the ribbon of air that we live in is only 3 kilometres thick. Relatively speaking, if the Earth was a 1 metre diameter ball, the bit of the atmosphere that we need to live in would only be as thick as a piece of writing paper. So imagine a ball that's a metre in diameter, and the little ribbon of air that we live in would be the thickness of a little bit of paper. And that's not a lot. And in real terms, 3 kilometres isn't much at all for billions and billions of living organisms on this planet to get essential air and water from. It is very thin, it is very fragile. So let's look at other causes of creating global warming, which follows on to climate change. The manufacture of laptops aside, as we've spoken about, have you ever noticed that when you burn a tank of petrol in your car, nothing of it is left except fumes? That's because all of your fuel, when burnt by the engine, is exhausted to the atmosphere. The average weight of a family car is 1.5 tonnes. The average pollution from a family car per year is around 0.6 tonnes of CO2 and other gases. There are 36 million cars on the roads in the UK, so that's 22 million tonnes of greenhouse gases pumped, mainly carbon, pumped into the atmosphere every year from family cars. That little ribbon is where it's getting pumped. Every 4 years, almost 1 billion tonnes of CO2 from UK family cars finds its way into that little ribbon of air that we need to live off. And that is just family cars. It's not counting the carbon emitted from power generation, other industrial processes, all the vans, buses, lorries you have ever seen, aeroplanes, boats, ships, railway trains. As time moves on, this thin ribbon of air becomes more fragile. All this from CO2, a trace gas we have boosted from 0.00029 of our atmosphere at the beginning of the industrial age to 0.00041. Today, that's 45% increase and the highest level it has ever been in 800,000 years. Such a small figure with such a potentially big impact. And do you still think it's not us? All that said, all is not lost. It's taken a long time to get us to where we are, but we know by looking at some of the things we did to stop damage before in the atmosphere, that in relative terms we were able to fix the problem. We can still do that, but we cannot do that unless we cease to do a lot of the things that we're doing today. It means changing some of the ways that we live, but we're doing this for future generations. To end, I would like to quote the great poet and filmmaker Jonas Mekas. In the end, civilizations perish because they listen to their politicians and not to their poets. Make of that what you will. This is Dr. Joe Murray handing you back to Hugh in the studio.
And thanks, Joe. That was fascinating and a bit worrying.